Hello everyone. In this video, we will explain basic problems on SURDS. This video is completely about solved examples in SURDS from lower level to little higher level. The first question is, which of the following is or are not SURDS? Is or are not SURDS? So once again, you try to remember what is a SURD. If a is greater than 0 and a is a rational number, then a to the power of 1 by n is a SURD. If a power 1 by n is not a rational, you can say simply a to the power of 1 by n must be irrational number. But that a must be a rational number and n is a natural number. So here you see which of the following is or are not SURDs. So the first one, we can write this is equal to 2 to the power of 1 by 2 whole to the power of 1 by 2. So we can write this is a power m whole power n. So 2 to the power of 1 by 4, right? This is nothing but 4th root of 2. So here this 2 is a rational number, positive. Okay. So therefore it is a SURD. You consider the second one equal to, this is outside is cube root, inside is square root of 32. So I can write this as 32 power 1 by 2. Again whole to the power of 1 by 3. So this we can write 32 to the power of 1 by 6. It is also a SURD. Because this 32 is a positive rational. This cube root of e, which means e to the power of 1 by 3, not a SURD. It is not a SURD because e is not a rational number. Since e is a irrational number. Irrational. So once again, you try to remember what is the SURD. Here I am writing let a greater than 0. A is rational. Means simply positive rational. N belongs to n. If a to the power of 1 by n is not a rational, is irrational, then it is a SURD. Then a to the power of 1 by n, or you can say nth root of a, is a SURD. So that inside the nth root, inside that 1 by n, here you see this a must be a positive rational. Now you see square root of pi. Pi to the power of 1 by 2 is not a SURD because pi is an irrational number. Similarly, this is a rational anyway. That cube root of 8 by 3, 8 by 3 is a rational, therefore it is a SURD. Now, square root of 2 minus cube root of 3, right? Okay, so here f is root 2 minus cube root of 3. So root 2 is a SURD, right? and cube root of 3 is a surd. Difference of two surds is a surd. Sum of two surds is a surd. So therefore, you can say this is a surd. In bracket, since root 2, cube root of 3 are both surds. Now coming to the last example, square root of 2 plus root 3. Square root of 2 plus root 3. So if we can write this as like this, that 2 plus here multiply 2 and inside divide by 2, 3 by 4. So this is equal to 2 plus 2 into inside one I can write 3 by 2 into 1 by 2. So this we can write here, you see this sum is 2, it is here. So I can write root over 3 by 2 plus root over 1 by 2 whole square under root. So this simplifies to, further it simplifies to simply root 3 plus, or you can say root over 3 by 2 plus root over 1 by 2. It is again sum of two surds, therefore it is a surd. Now express the following as a monomial surd. Express the following as monomial surd means it must be converted into a single term. Must be converted into a single term. So now you see the first one. This is equal to, this is 3 into fourth root of 5. Fourth root of 5. So you have to bring this 3 inside this fourth root. Well, so I can write this as 3 to the power of 4 power 1 by 4. And this is 5 to the power of 1 by 4. A power m into b power n, right? A power m into b power m equal to ab whole power m. So we can write this as 3 to the power of 4 into 5 whole to the power of 1 by 4. Similarly, this is equal to just this take inside the square root. So we can write this as 3 by 8 into 3 by 8 whole square. That's it. This is a single one. You can just simplify it. And this one is, you take inside this cube root. Inside the cube root. So we can write this as a cube root of 128 into this 4 has to be taken inside 4 cube, like this. So this is a very simple application of exponential laws. Okay, so if you want, I can write here. For example, a into nth root of b. This is same as of nth root of b into a to the power of n. Just take that a inside the nth root of b. Now here you can simplify this 1 by root 7 into cube root of 1029. So cube root of, I can take inside that this is 1029 by 7 has to be taken inside. So this is 7 into 7 into 7. You can, if you want, you can simplify them. This is, you can cancel here, you see 7 ones 7, 32, 7 fours 28, and 7 sevens 127, right? 49. By, you can write here 49. Similarly, you see this one. So once again, I am telling the fact that a into nth root of b equal to, when you are taking this a inside that nth root of b, you just write a to the power of n. For example, this is equal to, now you see, fifth root of a cube by b cube into, now take this b by a inside the fifth root. So you write b by a whole to the power of 5. Further, you can simplify here. You see here b cube we have, here b to the power of 5 we have. So one b cube will be cancelled. It is just fifth root of, in numerator b cube is left, b square. In denominator a square is left. Now you can simplify the sixth one. So here the main logic is a into nth root of b to the power of n, for example. So this a I can write a power n power 1 by n. Second one is b power m power 1 by n. Right? Here the power is same. So we can multiply the bases. So we can write a power n, b power m whole to the power of 1 by n. So these techniques are very, very important to simplify the expressions. Express the following as mixed surds. Express the following as mixed surds means some rational into a surd. Some rational number into a surd. Okay. So express the following as mixed surds, some rational into a surd. Of course, the first one is in the form of some rational into a surd, but still we can simplify it. This is equal to, this is 6 into 6 into, I can write this as 7th root of, or this 384 I can write 128 into this, I can 384 is 128 into 6. No, it's not correct. Into 3 whole to the power of 1 by 7. So this 128 we can write 2 to the power of 7 into 3 whole to the power of 1 by 7. Now 2 to the power of 7 whole to the power of 1 by 7 is nothing but 2. So this is nothing but 6 into 2 into 7th root of 3. 3 to the power of 1 by 7. If you want, I can write one more step, 6 into 2 power 7 power 1 by 7 into 3 to the power of 1 by 7. So this is further equal to 12 into 7th root of 3. Similarly, we can simplify this 4th root of 729. This is equal to 729 is nothing but 3 to the power of 6. 729 whole to the power of 4. This is equal to 3 to the power of whole to the power of 1 by 4. So 6 into 1 by 4 equal to 3 to the power of 3 by 2. This is further equivalent to 3 to the power of 1 into 3 to the power of 1 by 2. So therefore, 3 into root 3. This is the simplified expression. We can say it is a mixed surd. You can simplify the third one by yourself. Now, another category is which of given two numbers is greater? Which of given two numbers is greater? See here, cube root of 4 is given, fourth root of 2 is given, asking which one is greater. Well, so first number is 4 to the power of 1 by 3. Okay. Let us say this is A. B equal to 2 to the power of 1 by 4. Now, what is the LCM of these powers? Okay. LCM of denominator of powers. So here LCM of denominator powers 3 comma 4 equal to 1. Then, okay. So what we have to do is you have to raise each number with 12. So a to the power of 12 equal to a to the power of 12 equal to this is 4 to the power of 4. And b to the power of 12 equal to this is 2 to the power of 3. Now you see which is greater. This 4 to the power of 4 is greater than 2 to the power of 3. Okay, so 4 to the power of 4 is greater than 2 to the power of 3, which means that a to the power of 12 is greater than b to the power of 12. Here a and b are both positive, so you can say that a is greater than b. So what is simple logic is that suppose a is a greater than b greater than 0. If you raise any power, still the inequality is same. Okay, so this is vice versa. So therefore, a is greater than b, which means that cubed root of 4 is greater than fourth root of 2. This is very good question. Similarly, you can solve this question with a similar fashion. I'll solve another question here. Fifth root of 3, cubed root of 5. Assume this is a and this is b. So here a equal to 3 to the power of 1 by 5 and b equal to 5 to the power of 1 by 3. We want to take LCM of only denominators of powers of given numbers. So here what is LCM of the denominator of first power is 5, the denominator of second power is 3, the LCM is 15. Now raise the power 15. So a to the power of 15 equal to, you will get 3 to the power of 3. B to the power of 15 equal to, you will get 5 to the power of 5. So here, this 5 power 5 is more than 3 power 3. Or you can say 3 to the power of 3 is less than 5 to the power of 5. So a to the power of 15 is less than b to the power of 15. Implies a is less than b. So therefore, this is the greater one among these two. And this is the greater one, the first example among these two. So this is a very, very simple when only two simple surds are given. Only two simple surds are given. But when mixed surds are given, we have to apply a kind of technique. Here you see, we have to compare that root 7 minus root 3 and root 5 minus root 2. How do we compare? Which one is the larger one? Because here both are surds. So the procedure is quite simple. Let A equal to, you write root 7 minus root 3. You just multiply numerator and denominator by its conjugate. Because we can compare when sum of two surds are given. So this here, root 7 minus root 3, multiply with its conjugate and divide with its conjugate, followed by root 7 plus root 3. This is equal to, this is a minus b into a plus b. So a square minus b square. So we can write 7 minus 3 by root 7 plus root 3 equal to 4 by root 7 plus root 3. So we have simplified that denominator is sum of two surds, not difference of two surds. And the second one is b equal to, you take that root 5 minus 1, multiply numerator and denominator with its conjugate. So what is the conjugate? Root 5 plus 1 whole by root 5 plus 1. Well, this is equal to, this is a plus b into a minus b. So we can write this as 5 minus 1, 4 by root 5 plus 1. So now we have to see that which one is greater, A or B. If you observe that numerator in both A and B same, numerator in both A and B same. So we just have to compare only denominators. Only denominators. Well, now you see clearly root 7 is greater than root 5 or 1. Okay, root 5. Root 3 is greater than 1. Now adding these two, root 7 plus root 5 is greater than root 3 plus 1. Okay, so which means that here root 3 here and root 5 here, we are adding these two. Well, now you see this, the denominator of A is larger than denominator of B. Okay, so now you take the reciprocal, 1 by root 7 plus root 3 becomes less than 1 by root 5 plus 1. Multiply with 4 by root 7 plus root 3 is less than 4 by root 5 plus 1. So therefore, A is less than B. So B is the larger one. This root 5 minus 1 is larger without evaluating their actual values. It is sometimes very difficult to find out surds exactly in point-wise form. So root 7 minus root 3 is larger than root 5 minus 1. The same technique can be applied to compare these numbers also. Assume this as A and this as B. After multiplying by rationalizing factor, you will get this as 5 by root 17 plus root 12. Whereas B equal to, you will get 5 by root 11 plus root 6. Or you can use another technique, that root A minus root B into root A plus root B equal to, this is x plus y into x minus y. So you will get here A minus B. We want that root A minus root B. That's equal to A minus B by root A plus root. Here I am writing root A minus root B equal to, you can write root A plus root B. This is A minus B by root A plus root. So now you see here root 17 is greater than root 11 and root 12 is greater than root 6. Now adding these two, root 17 plus root 12 is greater than root 11 plus root 6. Without using this also, we can tell that root 17, root 12 values are more than root 11 and root 6. So therefore, we can write that 1 by root 17 plus root 11. Inequality will be reversed. To understand these things, you have to watch inequality, simple inequality. So therefore, A is less than B. Simplify the following expressions. Here, several kinds of surds are given, and we have to make them to convert into either single surd or as much simple as we can do. The first one is root over 63 plus root 28 minus root 175 plus root over 162. First term root over 63. So we can write this as root over 9 into 7 plus this one is root over 4 into 7. Because square root is given, so we have to try to bring that a perfect square inside the root. Minus this is 25 into 7. And the last one is, this is 81 into 2. So this gives us, here you see square root of 9 is 3. So this is 3 root 7. This is second term is square root of 4 into 7. That we can write square root of 4 is 2 root 7. Minus this is square root of 25 into 7. Square root of 25 is 5 root 7. This is square root of 81 is 9 root 2. So here you see 3 root 2 plus 2. 3 root 7 plus 2 root 7 minus 5 root 7. It is cancelled. So we got simply 9 root 2. Consider that the third example, you try to solve the second one. Third one is this root over 147 is there. Here root over 1 by 3 is there in second one. And this is root over 1 by 27. Well, so we have to express this 147 some perfect square into some number. It is clearly 9 into 9 ones, okay, 57. This is 49 into 3 minus 8 into, here inside the root, you multiply 3 and divide by 3. So you will get 9 here. Plus, this is root over, multiply by 3, both numerator and denominator. So root over 3 by 81. This is equal to square root of 49 is 7, 7 root 3 minus root over 1 by 9 is 3. So this is 8 by 3 into root 3 plus this is root 3 by 9. So here the fact is root over a by b, we can write that root over mod a by root over mod b. AB greater than or equal to 0. Of course, B not equal to 0. This is the fact. Now, everything expressed in terms of root 3 multipliers. So, this is, I can write root 3 taken out. Now, 7 minus 8 by 3 plus 1 by 9. You just try to simplify this number. Rationalize the denominator of the following. Only denominator. We have to rationalize the denominator. So rationalizing denominator, which means that we have to convert the denominator into a rational number. Simply remove the irrationality. So the first one is root 3 plus 1 by root 5 plus root 2. What we have to do is, we have to multiply with conjugate of denominator or simply difference of these two quantities. So root 5 minus root 2 whole by root 5 plus root 2 into root 5 minus root. Very simple. Just multiply that numerator and denominator with difference of given quantity in denominator. Root 5 minus. So in numerator, you can just multiply with as usual multiplication. Root 3 into root 5 is root 15. Minus root 3 into root 2 is minus root 6. Plus root 5 minus root 2. Whole by. Here a plus b into a minus b, this gives only 3. So this fully simplified. So the second one is root 3 plus 2 by root 3 minus 2. We have to rationalize only denominator. This is equal to root 3 plus 2 into, we have to rationalize the denominator. So you should multiply with its conjugate, root 3 plus 2. Here in the previous example, denominator, there is a plus sign between these two numbers. Here we have a minus sign. So here root 3 minus 2 into root 3 plus 2. The numerator is a plus b whole square. So a plus b whole square is a square. This is root 3 plus 2 whole square. Denominator is root x plus root y into root x minus root y. That is x minus y, or a plus b into a minus b equal to a square minus b square. Both you can use a plus b into a minus b equal to a square minus b square. And root a whole square is nothing but simply a. Of course, a is greater than or equal to 0. So denominator is 3 minus 4. This is equal to, now simplify this. This is 3 plus 4, 7 plus 4 root 3 whole by minus 1. Simplified. Here is another example, little complicated. Rationalize the denominator 1 by 1 plus root 2 plus root 3. So here we have sum of 3 terms. It is a trinomial. So you just think 1 plus root 2 as a one term and root 3 as another term. Okay. So what we have to do, we have to multiply with the difference of these two quantities. 1 plus root 2 minus root 3 whole by 1 plus root 2 whole square minus root 3 whole square. Well, or otherwise, again, once again, I'm writing that root x plus root y into root x minus root y equal to, or this is x minus y. Or you can say that x plus y into x minus y equal to x square minus y square. Well, so therefore, I want that you bring this 1 by x plus y to the right side. So 1 by x plus y equal to, you can write x minus y by x square minus y square. So these are simple manipulations of algebraic expressions. Now, coming to the question, we keep that numerator now as it is like this. By denominator, we have to expand 1 plus root 2 whole square. A plus b whole square. 1 plus, okay, a square plus b square plus 2ab minus 3. This further equal to 1 plus root 2 minus root 3 whole by. This value is 1 plus 2 root 3 cancelled, simply 2 root 2. So this is equal to, now multiply with root 2 only and divide by root. So we get root 2 plus 2 minus root 6 whole by root 2 into root 2 is 2, 2 into 2, 4. This is simple. Similarly, you can practice these questions. You have to rationalize that 1 by 2 minus root 3 plus root 5. You try to solve, or you try to rationalize denominator. So here I have simplified. You just try to observe that how I have simplified this.